Hey, just give me 5 minutes. Let's wait for 5 minutes. Others to join, and then we will start. Hey, hi. Can you guys hear me?
Yes.
Okay. Yeah. Sorry for the delay today. Yeah. Let's start. Let me just add the pent-up ones. And have you guys seen the previous video, which was about recursion backtracking? Because we are going to continue from there with the trees and all.
Yes, watched about 50 to 60% of it.
Okay. So you must have got the idea like what is recursion and backtracking, because whatever we are going to discuss today will be based on that only. Okay. Yeah. Let me just connect the pent-up ones. Okay, let's start. Have you guys seen the last part of the previous session where we talked about the trees and all? Yes, no.
No.
Okay. Okay, then I will try to start from the trees itself. We'll just give you the basic brief and then we'll continue with that. So, do you guys know like what is tree? Like, if I ask you to define, like how you will define a tree, if I gave you some structure, how you will say that it's a tree?
It is a collection of items or elements.
But in that way, then array is also a tree, linked list is also a tree. I mean, like in that way, multiple data structures will be coming under tree only.
It is unstructured, as I see, because there are leaves and there are nodes. So you have to traverse through leaves. So I believe it's unstructured data.
How it makes it unstructured if there is leaves under the node? I mean, like,
Because where we don't know where we have to start from. First of all, we start from any initial node, and then we traverse it through other nodes as well. So for that we need like we take this prefix and suffix thing while solving the question. I'm getting confused, but yeah, something like that. It has leaves, a lot of leaves over there. So which leaf you have to traverse through, you don't know. So you make use of optimization, or first you try random methods, then you make use of optimization.
okay, think of a tree like how the tree, how the tree grows. If you want to plant a tree and how it actually grows. So first there is a root which will came up, and then you will see some branches and then some fruits or
Yes.
maybe leaves. That's why we call it tree. When we say tree, it means that there is an ancestor node and there are some child nodes through that.
Channels. Yes.
For example, your file system. So you make a folder inside that. Sometimes you store some files and then you make another folder. Then you can go inside that folder and can store some more folders or the files. Because so that is basically what we call the hierarchical data structures. Have you heard this word called hierarchical? Just let me
Yes,
open.
because there are child nodes and they follow the same hierarchy, I think.
Yeah,
That's
so
why,
the hierarchy they follow is the parent and child node.
yeah,
The
parent and
child
child.
knows who are sorry, the parent know that who are their child, but the child does
Yeah,
not know directly that who are their ancestor or the parent one,
ancestors of
basically.
that.
So
Yes.
that's how you can define a tree basically. In a
Yes.
tree, every node you will find there will be an ancestor node. At the top there will be single node to which there will be multiple branches or some other nodes which you're going to connect it to that node. And then again they can have a multiple more nodes or the branches there. Let me show
Yes.
you the picture. Let me just share the screen. Just give me a minute. Is my screen visible to you guys?
Not yet.
Okay, let me just check it again. Okay, share again. Allow to share a window. This window. Now,
Yes.
great. Okay. So if we talk about the tree, just one second. Yes. So you can say there is a node, and then it is connected to some other nodes. 3, 4, and then it can also have some more children. Let's say 5, 6. It can have this one, then it can have this one, it can have this one, it can have this one. So what we are getting is a tree is a kind of a data structure or a shape where you see a hierarchical format where there is a parent always. So for example, in this one, this is parent. And these 2, 3, and 4 are the child of this parent, which is 1, 2, and 3. So you must have seen one thing in the file based folder. For example, if I just draw about the file structure, let's say, so you guys have a hard drive called C, D, and D. Let's say in the C hard drive, you have a folder called movies, something like that. Other one is, let's say, learning folder. Other one is, let's say, some others folder. And inside that, there can be some files, let's say like Avenger something, and there can be some more folders to it. So this is how the tree data structures look like. Is it clear now? Like what is tree overall?
Yes.
Okay, great. Now there's something called binary tree. So can you guys tell me like, so there can be multiple type of trees. One of the type of the tree is binary tree. And binary have only 2 values. So can you tell me like, then, I mean, if with that information, can you tell me what is binary tree? What kind of tree is binary tree? Sorry, I think my internet got stuck. Is my screen still visible or should I share it?
No, it's not
No,
easy.
it's not.
Yeah, now?
Yes.
Yeah, my question was, since so now you guys have got like what is tree, let's discuss about what is binary tree. So do you guys have any idea what is binary tree, since now you already know what is tree? I mean, in binary there is only 0 and 1 value, so there can be only 2 values. So with this information, can you think of like what can be the binary tree?
Yeah, I think a tree in which every node has only uh, 2 or less childs.
Correct, correct. So as you guys have understood what is tree, the difference, sorry, not the difference, like what is binary tree is, in binary tree, every node can have maximum 2 children. It can have either 0 children, it can have either 1 children, it can have either 2 children, but not more than 2. So maximum children which we can have at any node in the binary tree is going to be 2. Otherwise, it will not be called the binary tree. So let's say binary tree can be something like, yeah, 1, 2, 3, 4, 5, 6. So as you can see, at every node, either there are 0 child. For example, 4, 5, and 6, they have 0 child. There are one node at 2 and 3, sorry, at 3. And there are some nodes also where we are having 2 branches, or basically 2 children, which is 2 and 1. Okay. So this is what we call the binary tree. Now there are some other different kind of binary trees also, like full binary tree, partial binary tree, and all those binary tree. But for now, we don't need to focus too much on that. Let's first cover the basics first, then we will cover those things later on. Like if I just give you the brief idea, in full binary tree, it will be like either every node will have 2 children or they will not have any children at all, something like that. In partial, you can have something in between, so it's something like that. So have you guys got it, like what is binary tree?
Yes.
Okay. Now you guys have already seen like how to traverse all kind of data structures, whether we talk about the array, whether we talk about the linked list, whether we talk about stack, queue, all of them were having some operations or some way to traverse the values which were there. But this is not like as a linear, we can't say that this is a linear data structure which we are. So how we are going to traverse this tree actually? Because they were easy, like in array you just ran a loop and you got all the values. For linked list also you ran a loop, you got all the values. For stack also you ran a loop, then you just pop, peek, and all that thing, you got all the values. But how you're going to get the values here? One more thing to tell you is this is not a bidirectional. This some looks something like this, just to make it more clear. As I've already told you, parent node, parent knows about their child, but child does not know. The child does not have any information about their parent. Okay, 2 and 3 does not know who is their parent. Simple thing is that. So if you remember in linked list, okay, let's use the example of linked list. So if I draw the linked list was looking something like this. Now one knows what is the next node of two, and two knows what is the next node of itself, but two does not know what was the previous value. The same structures applies here basically. The directional, this direction is downward basically. So one knows the 2 and 3, 2 knows 4 and 5, 3 knows 6, but they don't have any information who are their parent. So how we are going to traverse this entire structure to get their values? For example, if I want to say, hey, I am giving you a tree, get me all the values of the tree. So how you will find it out? How you are going to traverse it?
By calling next method recursively.
By calling next method recursively. How? For example, let's start. Let's start some dry run based on what you said. Okay, so simple thing is like since we know the address of head, sorry, we know the address of this one, we can say that head will be like pointing to one, like the way it was pointing in the linked list, same thing. So first thing, we will easily get the values of one. Let's say we are creating an array where you are going to store all the values of the binary tree. Thus, you got the one. Then what is going to be the next step? You said
Uh,
record.
Yeah, so we'll call the same method on head.left and then head.right.
But tell me single by single. Let's say you called one left of one. So one left. Okay, great. We got the value 2. I pushed it. Then what? You can't call
Then
left
left of
and right
two.
in the same, like just a sequential step. Hmm.
Then we'll call left of two, which will reach at 4. Then again we'll call left of 4, which is null. And at that point we start backtrack. All
Okay. With the 2 to the left, we got 4. Now what? You said we will try to, should we try to check what is at the 4 left of 4 and 5? Sorry, 4 or not?
yes, we should check. Like only if it is null, then we'll return.
Okay, we will return to where?
Return back to previous function. Like
Okay.
then we'll try right, which is also null. Then again return back. So like our whole function is executed, then return back to the original caller of,
Okay.
yeah, and then again call right.
Okay. And do you know what we call this traversal? The one which you have used?
It's pre-order, right?
Okay. You mean first you are printing the root, and then you are going left, and then you are going right. So what we call this one? If you have like gone through the previous one. I think I have discussed about this in the previous lecture initially. I'm not sure whether you guys have seen it or not. But
Pre-order, right?
yep. So this was root, left, and right. Okay. Have you, so I think Surbi, are you able to understand like how we um okay, I think she left. Yeah. Yeah, Bipin. So have you got it like how we are doing the traversal on this? Yes, now?
Yes, sir.
Okay. Okay. And what are the other traversals basically? So this, let's say this one is pre-traversal. What are the other traversals?
In order and post order.
Okay. So as Sandeep mentioned, pre-order. This is pre-order. Let me use other music. So the one is the pre-order, other one is the in order, and the last one, which is post order. So as we have the traversal way for every kind of data structures like in tree, linked list, stack, and all those things. Similarly, for trees, we have three kind of traversals. One is the pre-order. The first one which comes is the in-order traversal, or like, I mean, numbering does not matter. The three of them are pre-order traversal, in-order traversal, and post-order traversal. There is not much difference in all of these three traversal. It is just the direction which you pick initially to find the thing. For example, the one which we just did is how we are doing it. Let me change the color. Okay, yeah. So first we traverse to this one. Okay, we printed this value. Then we traverse this to 2, which means we traverse left, basically. We again printed the value of this one. Then we have went to this left again a left operation. We printed this 4. Then we tried to check whether left is there or not. We printed the 4 already. Then we check whether left is there or not, but left is what? Null. So nothing there. We reversed back to this. Not reverse back, actually we were there only, but we will check whether 4 have left first, and then we will check whether it has right or not. But again, right was also null. So since there was nothing here, we returned back to 2. We backtracked, basically. Now, what order we are following is pre-order. So what are the operations in the pre-order which we do? These are the operations which we apply on every node of binary tree. Okay. You can only apply the left operation on any node when you are done with the root operation on that particular node. For example, if you see the example of 4, on 4, we first applied a root operation. Basically, we use that value somehow, or we printed that value. You can, for now, you can consider it in that way. Then only we applied the left operation on the same node. We check, hey, check if it has any left node or not. If it has, we were going to do one more recursion layer. But there was nothing. Then only we tried the right operation on the 4. And since right was not also there, we returned back to 2. Now let's come to 2. On 2, we have already applied root operation by printing the value. Then we have applied the left operation by when we reach to 4. That at that moment we applied this. Now what is the next operation which we should apply on the 2? It is the right one. So we will go to 5 this way. Basically right. Now 5. Now 5 is the most newest node. Basically, you till now you have not run any operation on this node. So what should be the first operation which you should apply in the pre-order traversal? It should be root 1, basically. Either you print the value or you use the value, whatever you say. Once you are done with it, what should be the next operation? It's the left traversal. Hey, check if it has any left value or not. But since there is nothing in the left, we will, what should be the next operation? Right operation. But since right is also nothing is there on the right, we go back to 2 now. Now on 2, you see, root operation is done, left operation is done, right operation is done. Now we will again backtrack to the upper layer, which is what? 1. Now let's come to this one, basically. Now we have came back to this one again. In this one, we have already applied the root operation. We already applied the left operation when we went from 1 to 2 because it was a left traversal. Now what should be the next operation? Since on 1 we have applied root also, we have applied left also. Now we are going to apply right on that one. So that means we will go to 3. Okay. Again, 3 is the most newest node. So we will apply the same operation, root, left, root, and right. So that's how the thing is working. I have explained the same thing in the previous session and also, so I will not like cover it more in that way, but I hope hopefully everyone have got the idea like how this actually works. Even if you are not able to think it, just apply the way I have applied. Simply write down the operation in the left, in the right, and whenever you see a new node, you will always start with the root, and that's how you can basically track the entire progress. Is it clear now?
Yes.
Yeah. Okay. For in order the
Yes.
traversal. Okay. Okay. So for in order the traversal operations are left, root, and right. And for post order, it is left, right, and root. there is nothing different which you are going to do. You just blindly need to follow this operation. For example, in pre-order, you were first going into root, then left and right. But here, first you go left. In the post-order, first you will go left and right, and then only you will apply the root operation. So that's how it's work basically. Is this clear to everyone?
Yes.
Okay, let's move on. So how we can code this thing now, basically? How we are going to code this actually? Now we need to code the same operation. Traversal seems to be more easy, but in code you are actually going to use the recursion. So let's see how the code will look like for all of them. Okay. Hopefully the editor is visible to all of you.
Yes.
Great. Okay. So we have three traversals. One is the in order, other one is pre-order, the last one is post-order. Let's do this one in order. So, okay. Now, first let's talk about the structure of the tree. In binary tree, as you have seen, there are two nodes, left and right. So if you guys remember in linked list, we have defined a class there for linked list. If you remember where we created a struct and all that thing. Similarly, we will do the same thing with the tree also. Can you guys tell me how we can write that code?
We can define the node structure.
And what will be there in the node structure?
Any type of variable, whether integer or string, whatever type of value you want to store that value, then one left pointer and the other one right pointer of the same type of node.
Okay. Okay. So let's say we are going to do this one. So what should I write? Let's say we are storing the integer down there. Okay, we can say something like this for now, or let's say value. Okay. Now what should I write in the next one?
Tree node left, tree node right.
Tree node left and the node like this.
Yep.
Are you sure we are not missing anything? Because according to me, we are.
It's in C++, so we need to apply pointer.
Okay. So now it makes sense. Okay. I think we have already discussed last time what do this pointer mean, so I will not recover it. It works the same way it was working in the linked list. In linked list, we were having next pointer. Here we are not just having one pointer, we are having two pointer. One is called left one, other one is called right one. So that's that way. Okay, so when we are doing in order traversal, we will have this one. Since in order traversal, what are the operations we use? Operations.
Left.
Then the root, then right. So the code will be very simple. I mean, you will see like it's nothing, but you may get confused when you try to actually use them while solving the question. Okay, hopefully I'm not using the correct conventions. Yeah, let's keep it that way. Yep. Okay, this is how the in-order traversal code will look like. This will print all the values of the binary tree in order fashion, basically. First, left, right, and all that thing, whatever we have done. Now, how the other will look like? Sorry. Yeah, got it. Right. Okay, let's write the code for the next one.
I guess like this one will give null pointer exception because we haven't handled the last.
Correct. So this way, if we keep going this way, we will get what? A compiler, not a compiler or a runtime exception, which says that we are trying to fetch the value of null, like null left, null right, and all that thing. That issue is going to come. So what we are going to check here, if we have reached to a point where there is no more values in the tree, we are not going to dig it anymore. For example, if you saw here at 4, we were checking that, hey, okay, let me, if I just dry run it, what will be the value of 4 left? Null.
Null.
So what we are going to call is in order null. And this one is going to be tracked here, and what it will do here, return, there is nothing there to do. So again we will reach to 4. Then what we will do, we will again go for the right one. What is 4 right? It is null again. So it will again return to 2. So that's how it is working basically. That's why it is required here. Now the same thing will be in here also. Here also. So what should change in pre-order?
We just need to print first.
Okay. So first, let's talk about this one. What are the operations in pre-order?
Root left, right.
So what we should do, just move this line and done. What are the operations in the post?
Left, right, root.
We are done. Is this code clear to everyone how we are doing this? By the way, in recursion and backtracking, I have left one thing in last 2 lectures, which was about how the recursion actually work, which is more about using not heap, like how we are using stack to do the recursion. I have not covered it because for now that was going to be too much. But later on, we are going to cover how the recursion actually work on the stacks and queues. Sorry, on the stack. Internally, it uses stack to track all the calls and all those things. But we will discuss about that later on. Is this code clear to everyone?
Yes.
Okay. If I ask you to find the height of this tree, how you guys will find it? Okay, let's start with a simple question. Find out how many total number of nodes are there in the binary tree. How you will find it?
And we can keep a count variable in the argument itself. And whenever we call left, right, we can increment it.
Okay, so you are going to use extra variable there in the argument. Are
Right.
you sure? Are you okay? When you are passing the value by the arguments, are you passing it by reference or are you passing it by value? Because if you are passing it by value, it does not make any sense. It will not, it like scrap.
Yeah,
It's
it has to be static. Like it has to be by reference. I
okay.
mean, like
It's a kind of a global variable. Let's keep it
right,
that way.
right.
Okay. Is there any other way? If I don't want to use extra variable, then what?
Maybe then we can try to return the count from the function.
How? Let's go back to the code. Tell me what changes should I make to make it work.
I think when the root is null, we can return from there we can return 0, and
Okay.
when calling pre-order and post-order, we can increment.
Do you think it will matter here which traversal we are using? Let's first ask.
No, it won't matter. Like the
Is
no remains same.
use in order then if it does not make any. What should I return here?
Like so, at this point there is no node, so we should return 0.
Okay, so I'm assuming then it will be an integer. So let's make the
Right.
return. integer, then what?
And then now we have to get this value at line number 57. We
Okay.
have to store some value, let's say left count. Let's call this local variable as left count.
Then
Now, when I'm printing this value, I know that I got one one value. So ideally, I should increment
increment what?
left count. No, no. Actually, first get left count, then right count, and then left count plus right count plus one. This sort of thing.
So are you saying that I should make it like this one? What should I return? Just tell me that. Now what should I return?
Left
But
count plus right count plus one. Because from the left null we got zero, from right null we got zero. Now I'm at my uh, leaf node. I should add one in the 0, 0 and then return.
okay. Okay. Do it without using extra variables.
I can just call the these, like, instead of left count, just call in order. Yeah.
Okay. Just for everyone, because you are going to see this kind of code very often, that people will not be using variables separately and they will just going to directly dump the recursive calls. So that's how you can find out the um, number of nodes which are present in the binary tree, and it is independent of what traversal you are using, because traversal meant is that, that it, in what way you can traverse the values of the binary tree. So irrespective of what traversal you are going to use, you are going to actually traverse all the values, so you will be able to count all the values actually at the end. So it is not, it will not, the answer is not going to change whatever traversal you use. And yeah, I think that's it. Any yeah, is this clear to everyone?
Yes.
Okay. How can I find out the height of this tree?
So
When I
like,
say height,
yeah.
go ahead.
So like, what's the height? Like, how we are defining it? Like the max depth, or like what?
From
Like,
top to the lowest leaf node is called the height. For example, just to make it more clear, for now the height can be 1, 2, and 3. Okay, for this tree. But if I say this one, what is the top node?
one,
What is the lowest node?
7,
How many nodes are there to reach from 7 to the top?
4.
That's it. That's, this is one of the technical way to um, say what is height actually. Although I should not have said it that way. It makes the question more clear and more easily how to solve it. But yeah, that's the way what we mean by the height.
I mean, now probably we just have to take the max of left or right, like whichever is returning the maximum value, we have to pass on that value to the upper node.
How we should code?
Like 4 will return 1, 5 will return 2, including itself, right? So we'll return 2 at node 2, like the node which has the value 2, instead of returning 1. Basically, max of 4 and 5,
Why we are doing this?
because we need the height of the greatest branch, right? Largest, or I should say depth. What should be the exact right word? Deepest branch, yeah.
Mm-hmm. Or longest, same thing. I mean, longest is also correct word.
Yeah, so like for that we need to return the maximum value.
Okay, so as for others, I will just reiterate the solution. So, just a second. Here is 1, here is 2, here is 3, here is 4. Just forget about the traversal recursion. If I ask you directly to solve this problem, how you were going to actually calculate it by in your mind. Let's say you are just in your 11th, 12, and someone asks you height of this tree. How you were going to calculate it? It would be, maybe it could have been like, hey, 1, 2, 3. Okay, the one of the height is 3. Great. Then 1, 2, and here. Okay, other one can be, let's say 2, something like that way. 1 and 3, again 2. So what is the maximum one? It is 3. So what we are actually what we were actually calculating is, we were calculating all the paths of the tree. That hey, 1 to 4 is one of the path, then 1 to null is one of the path, then 1 and 1 3 null is another path. Okay, and that in that way we found out all the height, all the possibilities of the height of the tree, and then we took the maximum one. Okay, now instead of doing that, what we are just trying to say is that hey, what if we try to find out the maximum length at every node? Basically, for example, consider, just wait, this dumb point, wait, yeah, consider that 4 is my parent node. Just imagine. So what will be the height of the tree with the, if the ancestor starts with 4? We would say, hey, what is the left and what is the right? If they both are 0, then we know that the height of the tree which starts with 4 is 1. So the thing which Sandeep mentioned is calculating that at every recursive call we were trying to find out that hey, what would be the height of the tree if the tree starts from the current node, which is, it can be in one of the recursion it will be 4, in another recursion it can be 2, and then in another recursion it will be 1 and 3. Okay, but what we need to find out is complete height of the tree. What that means, hey, what is the height of the tree considering that 1 is the root node? To find that out, we find what is the height of the tree if we consider 2 as a root node. What will be the height of the tree, height of the tree if we consider 3 as a root node, and then what is the height of the tree if we consider 4 as a root node? That's how we try to find out the solution. If I write it in a mathematical kind of way, you can say that hey, height of ht, let's say height of tree, you can say ht is height of tree for of 1 will be equivalent to maximum of ht2 comma ht3. Now if you guys must have remember the Fibonacci series. If you guys have seen my previous session, you must know, like in I wrote one of the solution for finding out the Fibonacci by using the recursion, or did some binary search also. So you see here, now to find out the height of the tree, which starts with 1, we need to find out the height of the tree which starts with 2 and which starts with 3. So now what would be the formula for this one? Max of what? H T4, if I'm not wrong. Okay. And there is nothing here. So either we can say 0 or like whatever you want to name. Then what? HT of 3. Again, it's like simply 0. I mean, there's nothing more to think about it here. Now here, if you see, H3 does not need any other thing. So if you guys remember, in every recursive call, there is some base condition which I have explained in the previous session also. For example, in Fibonacci, it is like we already know that hey, fib 0 is 0, fib 0, and fib 1 is 1. So these are the base condition which we already know. So here at HT3, we hit a base condition where we already know the answer. So now we are going to use it to find out some other answer. That is one of the things which I wanted to like mention it here. Now, if you see, H1 needed H2 and H3. We have got H2 already, but for H2, now we need H4, HT4, sorry. So we are going to calculate it. Again, H24 will be kind of a 0. Or you can say 1 actually. They will not be 0, they will be 1 because 3 is itself considered as a height. Okay. if I draw the recursion tree for this one, it will look something like this. Four. And for 4, we already know it's 0. And for this, we already know 0. Now let's try. So this is how we are actually find out the thing. Let's now try the formula. Now let's start backtracking basically. We got what is the value of H4 and H3. What is that? It is 1. And for H3 also it is what? 1. Now what is the value of H2?
2.
2. Now what is the value of H1? Sorry, just yeah, just changing one thing in the formula which I messed up. It will be 3. Why? Because HT1 is says maximum of H2 and then H3. What is the maximum of H2 and H3? It is 2. 2 plus 1 is what? 3. So height of the tree, if the tree starts with 1 as an ancestor node, is going to be equivalent to 3. Now with this way, you can find out the height of the tree with any of the ancestral node. Like considering that if question asks you that, hey, what will be the height of the tree if we consider 3 as ancestor node? Although that question does not come up, it's a bullshit question. But this is how basically you can think about how we are actually finding out the height of the tree. Okay. Hopefully now it is clear. The code should be also clear, like how we are actually doing this here. Sorry, I think this was not for that one. Sorry. Yeah. Is it clear how we are actually finding out the what is this one? Height of the binary tree?
Yeah.
Great. Okay. What should be changed in the code here?
Like we just need to apply max. Yeah, till here.
And we are done.
Right. And comma instead of plus.
Yep, correct. Okay. Any questions till now? Do you, if you have read anything about any question till now, whatever we have discussed? Okay, seems no. Find out all the leaves node of this tree. What is leaf node? Can you anyone tell me like what is leaf node? When I say
node,
leaf, like leaf kind of. Okay, yeah, good.
like a node with 0 child.
Yeah. So a node which does not have any left side also and does not have any right side also, as he said, 0 child, we called it as a leaf node. So find out all the leaf node of any given tree.
Like we just need to print or we need to store somewhere.
Um, if like I mean, there's nothing much different. If you either you will route C out condition or you will just push the array to a global variable in that way. That's nothing a big deal.
So, like you just simply apply the condition if left is null and right is null, both are null, then print the node. Like node dot left and node dot right is null, then only print node.
Where that condition will go.
Base condition.
Okay, so instead of having this, um, so will it go above 64 or will it go below 64? Or do you think we don't even need 64?
Yeah, like we don't need in that case 64. Like after printing, we can just return.
But if we get the null tree at all, we just get a tree which initially starts with null. Although it does not happen, but still. And again, there is one more issue there. If we don't use line number 64, there will be some child which have left node but does not have any right node, and you are still going to call the right node when you call the line number 6. I mean, you are definitely going to call root left and root right every time until and unless you are preactively checking whether they exist or not. Are you going to preactively check it?
Uh, that's why we are doing this now. Like left is null and right is null.
So that condition you are using to find out the leaf node. There will be ampersand condition there. So I mean there is going to be end condition here. That means if left and right both are null, then only that condition will trigger. What about if one of them are null and the other is not? And but about like yeah, I mean yeah, definitely. If one of them is null and other one is not, then what? Don't you think we will not we will need to have the line number 64 until and unless you are saying that hey, call in order root left if and only if root left is not null. Are you going to write that or not?
Yeah, like that is the one way, or otherwise we can just keep this condition as well to return an
Let's say if
original.
we keep this condition, then where will be the new line will go? Will it go above 64 or will it go up right after 64? The condition which you said that hey, if left and right both are null will return, yeah, will output the leaf node. That line
Mhm.
should go where? Before 64 or after 64? Like this is my question.
Okay. Like I have to visualize for that, but
I don't think so. You need to visualize much. Just it will straightforward go after 64. When you are checking anything null, why you are checking? Okay, let's start with the basic question. Why we are? If you remember in the linked list, while we were writing the while condition, we were always checking that hey, the value which we are actually going to access, is it a really a value or not? If you remember, we were writing while hey head should not be equivalent to null, then only run this while. Why we were checking it? Because we were going to use the value which exists at that thing. So we were assuming that if a line code or a line is going to get hit, we were assuming that hey, if something exists there. Otherwise, we were going to get the runtime error. Always these checks come at the top. So if you are going to use root left and root right, so don't you think you will have to check whether root exists or not preemptive, like before even you hit that line?
right. Yes.
So we can say that root, sorry, value, and we are sorry, yep, we're done. Okay, so you don't need to think much or visualize that much. It's just a simple thing. This is a basic check which you are going to do while you're going to code. You are going to like do it, see it multiple code lines. Like whenever, even if you're writing an object, you first check. Let's say you are calling a API. I'm not sure whether you guys have done the development. If you're calling a API, let's say, and you are trying to fetch some data, and in the return, you get some empty object, but you are assuming that hey, object comma username, you will just try to hit object dot username. You will run into some errors, or you will actually expose something which is not meant for the user. So you always need to check when data is not in your control, and you always need to preemptively check whether it exists or not. So you are going to do it not here, like in multiple places, like in stack also you do it. Hey, if is stack empty, while popping you always have to check if the stack size is greater than 0 or not. Otherwise, if you do the pop, you will get a runtime error. So make sure while you are coding, make sure you are not like making these mistakes. This is like just a simple check which always should be there. Okay. uh, yeah, I think this, yeah, so this is clear to everyone, like how we are getting all the leaves value.
Yeah.
But what if I ask find the maximum of entire tree?
Maximum value of entire tree.
Correct.
Yeah, like then like instead of doing this +1, we will just simply return the value. Like instead of returning 0, okay, so we need to return at this point, and the second line as well. Like in the code where we just find the leaf nodes. That point we'll need return node dot value
Okay.
0 or -1 in cases of leaf node. Okay, so value can have negative value or not, like the
Yes.
three nodes.
I mean, it can have a negative value. Yeah, I don't think so. Even I need to tell you whether they can be negative value or not. I don't think so.
So it
That is
will
required to.
return negative infinity in case of null. And in case of line number 65, we return node dot value. And then
Mhm.
in 17, we just keep max of in order and in order of left and in order of right. And we'll remove this +1.
Can you write the code and send me on the chat?
Yeah, sure. Like it looks similar to this.
Okay. Okay. Is it clear to everyone? Like how we can find out the maximum of all the values? Okay. Seems yes. The next question can be find out whether the tree can be a symmetric tree or not. Whether tree is a symmetry or not. Okay, I will take a 5 or 6 minutes break. Okay. Now for what is symmetry? Symmetry, you can say if you so you all you know now that if you see anything in mirror, then the rotation happened basically. Like if you're right, if you are your right hand will look like a left hand in the mirror. So when we say that if to find out whether the tree is symmetrical or not, you need to find out whether if we check the mirror image, if we compare the mirror image of that same tree with the existing image, with the real one, all the values should be equivalent. Okay. Since I'm taking 5 minutes break, you guys can like do internet research, whatever you want to do to find out whether what is symmetry, and then try to come up like how we can find out whether a tree is a symmetry or not. I'll join back at 10:40. Yeah. So how we are going to solve this problem? The symmetry one. Are you guys there? Hopefully I'm audible. Yep.
Like initially, I thought that we can just check pre-order and post-order, but like that's wrong. It won't
Mhm.
work. Like we can do one thing. We can keep two nodes during traversal. One node will like first traverse to left, and the other one will traverse to right. And then in pre-order, we'll keep checking if my node values of left traversal value and right traversal value is same. Then we'll return true. Otherwise,
Can you
false.
start from beginning again? I didn't get it.
Like uh, let me send the code. Just a second.
I'm assuming C1 and C2 are the nodes. They are
Right.
initial. What will be the initial call?
Like the last line is the initial, like which is calling the helper root dot left and root dot right. So like I'll just simply pass the left and right at the same point.
I see multiple issues. Okay. There's an issue which exists on the line number first itself. You're saying that if C1 is equivalent to C2, just return true, which is completely wrong. Why you are not checking rest of the values which are below that? You should say like if C1 is not equivalent to C2, return false. So okay, while you're trying to find something whether something is true or false, there are two ways always. Either you try to find something which is wrong, that can be one of the approach, or you can say, hey, I will find out whichever is true. In this case, it's better to find out if any value is not equivalent to is not equivalent actually, and then only return. Otherwise, you always need to go to the depth. You can only halt the process in between if you find out even one single inequality. In your case, you are saying, hey, even if I find one of the equal nodes, I will just return true. So that is where I see one of the issues. Okay. Other one in the next line itself, you're saying that if C1 is equivalent to none, I'm assuming it none means null here in our language.
Right.
And, and if okay, if one of them are okay, let's first assume first condition, both of them are not null, then this condition will never hit. Okay. If this does not condition never hit, then let's go to the next return. C1 is equivalent to C2.
Like even if both are same, then still then we are going like down traversal. So like the first condition which you said
But
that
the issue is, I just have one question. Like, I mean, what you're trying to check in the C1 equivalent to C2? Because when you compare C1 to C2, I'm assuming you are comparing the address of them, in at least what I have understood. Because you are not saying C1 dot something, C2 dot something. What are you trying to find out in line number one, which
yeah,
is
yeah, like I guess like this thing can be replaced, like this thing can be omitted. We can like the first value in the return, like are you saying that C1 dot val equal to C2 dot val?
Mhm.
So like that thing will do the thing which we doing here,
But
right?
even that will be wrong if you say that, hey, I want to write for at first line C1 dot value should be if you are saying that, hey, I'm going to write in this way that C2 C1 dot value equivalent to C2 dot value then return to, then that is also wrong. We cannot halt the process just because we find one of the equality. We can only halt the process if we found one of the inequality. If you want to find out whether a tree is symmetry or not, a tree is only symmetry if all the values are equivalent.
Like we are not halting, like if it's true, then we are using AND operator, right? It will still go for the next call.
I was talking about the first if condition, not the last one. Last one I get it.
Okay. Yeah, first one. Yeah, first one can be omitted.
Okay. Mhm. Then C1 dot left, then C1 dot right. Okay, then C1 dot right and C2 dot left. Last line makes sense for me. Okay. Okay. Then what you are doing here? It's C1 equivalent to none. What are you trying to do in the second condition? In the second if condition of the loop.
Like if any one node is none, but the other one is not none, like the left or right child.
Then you should directly return false, no?
But like hmm,
If you are saying, hey, my condition is for those conditions where one of the value is null and other one is not, then it's a simple case of that, hey, the tree is not symmetric. It's a straightforward case. And again, I'm not getting it like, oh, what do we mean by the C1 equivalent to C2 every time? In there also you are returning C1 to C2, which is fine. You will still get the false. That is fine. But okay. I just have one question to ask. So when you compare this thing in Python, which is C1 and C2, are you comparing the address or are you comparing what? When this
yeah,
you
no,
write.
when we write C1, C2, it's location only, one location.
So don't you think it will always return false because two nodes will have different location all the time?
Correct.
So that means there is an issue there. Either you directly return false instead of writing this one then. If you are looking to return false always. Okay. What if they both are if what if they both are null? Then that is bigger issue for me. If they both are null, na, then you need to return true and move on. You need to return to not false. But in your case, you are returning false actually. Because you are using or, you are not using when you use or, if one of the value is null, great. In that case, it will work fine, considering that return will be always false because address are always different. But if both are null, then it is a true condition. You need to return true, not false.
Like if both are none, then
Yeah,
none,
then it's true.
none,
I mean, null is equivalent to null. No?
right?
So you should, don't you think you should return true there?
So like we are doing double equals to only, no? Null double equals to null.
What are you trying to say?
I mean, if C1, C2 both are none, then it will return in like it will return true only, no?
But okay, I just have one question there. I specifically ask you. So you said that C1 and C2 are the location.
No nodes basically, yeah. Like
Are
yeah,
they nodes value or the location?
like you can call it a combination. Like no,
So it
it's
is, I will tell you.
address only, but none equals to none is
No, I will
like
tell you one thing. Even for null, you need to store it somewhere. Null is also an information. Okay, when you initialize a pointer, you can okay, what if I write a line where I'm defining a pointer and I'm setting it to null? Don't you think it is using a memory? Just because it is pointing to null?
right,
I mean, based on our initial conversation, I was considering that C1 represents address. So if C1 and C2 both are addresses, definitely they will not be equivalent. Because you are initially, because even from beginning you have separated the branches. There's no way their address can be same.
yeah,
Because tree does not merge later on at all in any way.
right. Like the concept of address doesn't exist. It's node only. Like the node holds the value. Like why I'm saying address, because the node has to be the exact same node.
Are you saying that if C1 is a null and C2 is also null, then it will return true?
Yeah,
Okay, then I will assume it then. Okay, it will return true. Okay. In that case, it seems fine, except few things I think which you discussed. Yeah, but we can say we can maybe write this thing in a better way also.
Yeah, like I think like what you said initially, that we should halt at the falsy condition, not at the truthy condition. There can be a lot
Yeah.
of
If there is anything wrong, then return. Otherwise, keep going on. So
right.
let's see how we can write it. So, sorry. Yeah. So hopefully my screen is visible.
Yes.
Okay. So as you said, we are going to have root 1, I can say, then root 2. If root, okay, I'm not sure should I use it or not actually, but okay. If one of them is null, then what we should do?
False. Yeah.
If both of them are null, then what we should do?
So,
We should return true. Simple. Sorry to not use 1 and 2. Hopefully you get the line number 75 what I'm trying to do, although I have not explained it before. Okay, that can be another condition, can be what? Otherwise, check symmetry. What? Tree not, sorry, root 1 left, comma root 2 right, ampersand this one, then what we can say is right, and the next one is what left. Does this make sense?
yeah.
Is it clear what we are doing on line number 75? If you have you used the XOR operator before?
Uh, okay. I consider that it's a okay. So like I assume that it's or only.
No, it's not OR. If it was OR, don't you think I was not going to write 76 then? I mean, 76 would be included in 75 actually in that case.
Right.
Have you used the XOR operator before?
Yeah, like only for same values, like for same values, it returns 0, like ones or one.
So
Like
if the values are same, it returns 0. That means line number 75 will never get hit. Our focus should be on true condition. What are the conditions where it returned true? If one of the value is true. Okay.
can you please repeat like what did you say?
The XOR operator returns true when one of the value is true and other one is always false. One should be true and one should be false.
Okay.
In that case, it returns true. And that is what we were looking for, to return false. If only one value is null and other one is not, in that case, what we should return false. If both are null, we need to return true. If the value is not equivalent, then we need to return false.
Okay.
So XOR is not OR actually. So I mean, I could have write it in that other way also, but okay, let me rewrite that line. Not here, but I will write. So this can be rewritten as
Root 1 null and root 2 is not null, and the other way as well.
so 85 and 87 are equal. But 85 is going to be much faster since it's a bitwise operation. Yep, that's it. Does this make sense now? So
Yes.
if you want to use it, you can use it later on. But yeah. Okay. Is this code clear from line number 74 to 81?
Yes.
Okay.
So like in Java, when you compare to node values, so that will compare memory only, right? Like it will not check the root has to be exactly same as to the other node, right?
Can you come again?
So like here, if we do that thing like root one equals to root two, then
Mhm.
it will only check memory location, right? It won't check the exact like root one has to be equal to root two.
In Java?
Uh, in Java or C++, in both
In
like
C++, I'm sure that in when you compare root one to root two directly, basically, and if you are not using the pointer, root one and root two without using the pointer are representing the information, are representing the address of that node where that information is stored, basically. Okay, even you can try that actually. Let's do one thing. Just try to print it this way. There is an operation in C++ with which you can try to print this one. I don't remember right now, but this represents the
address.
address. And now if you want to change anything there, you can write something this way. Star root one. And here you can directly replace the value at that place actually. For
Okay.
example, let's say you said that, hey, root root left is root one and root right is root two. Okay, now root left is pointing, the address is stored at root 1. So you can directly go there and manipulate the data of the left node. You can say, hey, new, something like this also, and that will automatically get changed.
Okay.
Okay, you can just try to play out that. It has been long time now I've played with this, but yeah, you will get the idea how these things actually work. So, yep.
So like in here, we don't have any function to like in one line, we cannot check nestedly whether both nodes are exact equal or not.
What do you mean when they are,
Like,
I mean, equal?
I mean, like the address is not same, but the all the other parameters are same. Like the
Other
value,
senses what? Left, right?
value and yeah, left, right as well.
You saying so one thing is every node here can be another subtree. So it's not just a single value. It can have a long chain of tree. And if you are saying that, hey, then it's like saying that, hey, can I compare two subtrees in one line? Can you do it? No.
No, right.
And you will have to traverse all those trees. Either you do the pre-processing and then yes, you can do it. So one of the way can be you write the in order traversal for every node specifically in terms of string.
And call it at every node. Okay.
Yeah,
Yeah.
and then you can find out, hey, what is the hash for root that one, and it's, yeah, you can do it. But you need to make sure that you use the same traversal for everyone and you have a perfect structure for hashing those values correctly. Actually, even the null should go there. So yeah, I mean, yeah, and there are multiple things other also. You need to consider that tree as a full tree. I mean, there are like multiple more things there to consider actually. For example, you can't say, hey, I will not include null in terms of when we are hashing the value because the structure needs to be correct.
Right, right. Yeah.
Yeah. Any other questions?
No.
Okay. Now, what if I ask return a 2D array where you are grouping the level, um, all level nodes. Okay, I mean what I meant is this should be in one array, 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 and then return that 2D array basically. How you will do it?
like somehow we have to keep track the, like we have to keep the track of the level, like at which level we are. And for each level, we can maintain a list.
Can you come again?
Like somehow we have to keep track of the level. Like we can,
How?
either we can pass it as an argument, or like, can we return the level? No, we can't return. No, we have to keep it as an argument only. So like at one, uh, I'll keep the node and the level. So level is 0. And when I'll call left and right, I'll call with level like +1. Like, so if it's 0, then for 2 and 3, it will go as level 1. And then in pre-order, I'll just add the element at that index list. So if it's one index list, I'll add 2 or 3 in that list.
Okay. Can you write the code?
It might take some time, maybe.
Okay. Let's discuss then why it will take time, because it should not. So let's say the tree is something like okay, I just need to draw it carefully. It's all right. So we are having two things: tree node, and the second one is the level. This will start from 0. How you are going to store it? Like, since you need to return the 2D array, how you are going to arrange it? Because
List.
it's a 2D array, not a single array. That you can't just keep pushing. So how you are going to do that? And you don't even know what should be the height of that, not height, actually the size of that 2D, because you don't know the height of the tree also.
Like, do we need to have a fixed size of list? Like we can keep
No,
list of list, like,
no. It's not necessary to have a fixed size of the list, but how? I mean, how you will get to know? For example, if you went to level 1, then you know you need to store the information in the
okay.
second.
Yeah, yeah. So I guess like we can create a new list whenever we encounter a level for the first time. So like in the
How we
list,
will get to know
like
whether how
the
we will
length of
how we will get to know whether we have encountered that level first time.
like the length of my original list will give me the last available.
You will find out what is the size of that one, and if it is below the current level, then we know that hey, we have not seen this level yet, and let's create an empty array and start pushing it, and that's all. Okay. Okay. So the way we are going to do it is we will start from here, tree node, and then the level will be 0 here. We will check here itself. Okay. Let's use post order traversal. Okay. So what we will check here, hey, check the size of my answer array, let's say ANS 2D array. Hey, size is true and level is also 0. That means we need to push an empty array here. We pushed a new array. Now the array looks something like this. Okay. Hey, at array 2D, at array 0, push 1. Done. Next, we came here. The level was 1. Okay, now we checked it again. Hey, I mean array 2D is like the size of array 2D is 1 and the level is also 1. That means we need another array. Just push 1. Now the next operation is an ANS 1. Here the level goes. Whatever level, just use the level variable here dot push what 2. This is how you need to do it. So how, like, what is that thing where it will take time? I mean, why do you think that the coding will take time for this one?
Uh, like the coding,
Mm-hmm.
like it depends. It might take time or it might not take time. Like there would be definitely be some errors. That's why I said it will take time.
Okay, let's then try to code it. What we are trying to find out?
Like why you mentioned post order only, like we can do it in
Yeah, we
any.
can do it in any order traversal. Does not matter at all.
Okay.
Okay, it does not matter. The issue, yeah, I will tell you one issue with other traversals. I will tell you that if you use other order traversal in that way, you will hit. Let's say in pre-order traversal or whatever traversal I was using, I was always hitting the root first. So in that way, I am able to create this ANSD 2D first time. But let's say you reach the last node, which is 5. Now what is the level of this tree? Level of this node? 3, 2. How many time you need to do the push here? 1, 2, and 3. So that is the only difference which is going to be there. Nothing else is going to be there. That's the only difference. So here, when I was using this, when I was using the post traversal, I was only pushing the array single time because I was traversing the route one after another. That was the way. But here, you will hit the root node at the last node. So that means you will have to create the entire structure there itself. So the number of time you will push the array to the answer 2D will be dependent on the that level. That's the only difference. But it's not like anything is going to get changed there. That's just a simple thing which you can like manipulate or like change the code. That's it. That's the only difference I see. Other operations are exactly same. Clear?
Yeah.
Okay, let's write the code. What we are finding?
Level wise ordering of element.
Let's keep it simple. We got what? We got what? Simple check if root is equivalent to null. Return nothing. Okay, I will create a global array. And then we will start talking about some more things in the same question. So now let's keep it this way. Let's have stored it like okay, this way. If level 2D dot size is equivalent to level, then what? Level 2D dot push back. Done. Okay. Now level 2D level push back. What should I do? Root value. Done. Now what should go here as root left comma 1, sorry, level plus 1, right comma level plus 1. Yeah, is there an issue in this one?
No.
Okay, the first call will look something like this, where you pass this and you pass 0. Done. Okay, yeah, okay. What if I don't have global array and I don't want to use the global array? But how we can do it then? You
Like
can't
the
use,
replacement of global is to pass it in parameter.
that's not the, but then you will have to okay, you will pass it by reference. That would make sense. It will work. Is there any other way? Let me make the question more clear. The question is, you are given this function. You can't create any other function. Just use this function and get the answer. You can't create any other function and say, I will create another recursive function. I will just use it, pass it, and done. No, you can't use it. You can't do that. Now, how should you do it?
Every time we have to return a 2D array.
Mm-hmm.
Okay.
I mean, I'm asking, is it possible or not? If it is possible, then how? Yeah. Is it even possible?
Not really sure.
What if I say that this represents the level array tree for every particular node, like the way we did for the other questions, HT1, that one, the one which I used. What if you think in that way? So when you are calling this recursion, whatever they will return, it will always go into the next level.
Right, but at last level, how you will merge, like the left and right will return same level arrays, right?
Sorry, can you come again? How they will return same level array? Sorry, yeah, they will return same level array, but their sizes can be different, and you just need to map the sizing. For example, okay, simple thing. Let's say 19 and 20 return the array. 19 is having a size of 2. The 21 is having a size of 3. First two, same thing. They will go into the same level. The next one will go to the same level. And third is one the extra one, basically.
Right.
So this question, this manipulated question is more about writing the code actually. You can always think it, how you will write the code for this. And are you getting it, like how you are actually going to do it? Because the merging is going to happen at every backtracking. After number 20, backtracking will happen, and then you will always have to do the merging, and you need to be really careful there actually. Tell me how we can do it. Okay, merging will happen. Does this make sense, or should I complete the code? Yeah, this may not be the best code to be written. This may not be the efficient one. I'm just trying to explore your thinking, that how you can even, like, how you can tweak the codes to get what you want. This may not be the best practices, but in multiple questions, you are actually going to do these things. Whatever pattern you have learned, you are actually going to find some tweak there, or like make some few line code changes there, and it will make it will work out for those questions. So you really need to know how to code out anything. If there is any possibility to do something with the code, then you should know it how to do it.
Right. So like ultimately at last we are just creating a new array. Like this last part when we are creating answer. Uh,
You mean line number 30? Should I write the entire code in line number 37?
yeah, like once please.
Okay, just give me 2 minutes. If someone is on the door, I'll come back and write the entire code.
Yeah, sure.
Yeah. So there are two ways to do this merging thing. Let me initially start with the easier one. Whatever. Okay. Now,
So like at line number 30, you are adding.
so that's just nothing. Forget it. Yeah. So at the time of backtracking only, I'm going to do whatever I want, like what I need to do. Nothing else. Before that, we are not going to do anything. Okay. So we are getting this thing. Okay. We had this one, which is this one. Okay. Okay, I should eventually say this one. Okay. So this is done now. Okay, I will just do it for the left one, and similarly it goes for the right one. Sorry, just one thing left. So now you can either create level plus I. So level, let's say, is 0. I will be also 0. So there should be a +1. Okay, yeah, now it makes sense. So this is how we are going to do it. Similarly, it will go for this one. Here, what will happen is if the tree is unbalanced from left and right, then only this line will actually eventually get it line number 47. But we would require this. Okay, what we have to change here is this one. Hopefully, this one. Does it make sense to you now? So yeah, one more thing. There can be order. Yeah, I think order will be also same. Yeah. Does this make sense now?
Like now, while going down, we are creating an array and then inserting elements like the inner loop. Like what's the logic?
The array which we are getting is a 2D array. So inner loop. If you want to get the value, you will have to go to the inner loop, no? Even if you want to push all the values to the array, you will have to go to inner loop. I don't remember the function where we can directly put the subarray, but you can do that also. If you mean that, hey, why we need to go to inner loop because you are coming from Python. So maybe you are trying to say, hey, why can't we directly push the? Do you mean like how why can't we push directly a array to a array, something like
Yeah,
that?
like why we can't push the at the last, like once we inserted an empty array, we then just need to maintain the level of I. Like this j loop doesn't
What
make
should, according to you, okay? If I ask you how you will replace 41, 42, and 43, what should be written here according to you? Let's write it and then we will compare what's the difference. What should I write here? Let's forget like 40. Let's consider 41, 42, 43.
instead of level plus I plus one dot append left of I.
Yeah, that will also work. As I said, I don't remember the function where we can directly push the um, array to a directly an array, something like that. I'm not sure even that function is there in C++. So you can check it out. Since you are coming from Python, I get it. Like in Python, I know these things are there. Yeah, that is same thing. Exactly, it's the same thing. No? That's what I'm trying to say.
Okay.
You may say that, hey, I am appending it, but do you know how they're doing it internally?
Yeah, internally they'll use a loop only, I guess.
Yeah. So, yeah, that was what I wanted to say. This is how you can do it. Other way of writing the same thing can be you will run a while loop for left and right simultaneously. There will since if left and right have unequal size, then you will for those cases you will write another while loops. Okay, if you have done those questions where I think there was some question about merging two sorted lists. Have you done that question? I'm not sure whether it was there in the list.
Yeah,
So you must have written those functions there. Like there you must have wrote the three while loops. I'm not sure how you solved it. Yeah. Okay. If you have written it, then you know how we can rewrite this code from line number 32, 39 to 51.
yeah, like that thing I got.
And in that case, you will not even require level actually.
Like we don't require what?
You will not even require this level thing.
No, like level thing. Why we won't require level thing? Like level is essentially because once you go to the left subtree.
According to me, I should not even use level here, frankly. I think I missed it, but I missed this thing. Level should not be here, actually, at all. I'll tell you. Why? I'll tell you that thing. Just 1 second. There are few mistakes which I have made. Level is not required here. Okay. Level is only required when you are doing the things globally as such. Because we are merging, then why we are even need to merge it? We are already passing the level, directly push it. I will not even pass the level. Let me change the code exactly. Completely. No, I don't even give a shit to the level, frankly. Yeah, now this is more interesting. Okay. Tell me now, does this make sense for you? Okay, even this level, I don't give a shit. And guys, to the sun. So yeah, does this make sense now? We don't need level if we are doing this thing. At least for in this question. Are you there?
Maybe I'll dry run it once, uh like uh, because I'm not getting that part. Once we have traversed the whole left tree, then
Let's
we
come to the
again come back to right.
visualization here. You came here like array 5.
Right.
Okay. You are at the point where you are going to start backtracking from 5.
Correct.
At that place, you will create a 2D array. You will do this. That till that point you got it. Left and right are 0. So nothing will go here, nothing will go here. There nothing. Clear?
Right.
You came to 2. For 2, left is 0,
Right.
right is what? 5. You will only use this at the time of backtracking. Let's say we have reached to the stage where we will start backtracking from 2 also. At this stage, you will create a new 2D array. Initially, it will look something like this. Does this make sense to you?
Right.
Right? What I'm trying to say is push this at the end. That's it. For this thing, why we need level?
Like
The,
at
the steps are sequential. The steps are sequential. You go to the bottom. From bottom, you return a list. From second bottom, you push the value to the next. From third bottom, you push the value to the next left. Next value. Why we need the level? We are not jumping here from one place to another place in any way. It's a sequential steps. You
like
are merging at every stage.
when
Go.
uh go to 3 from 1, right? The 3 has to be appended in the list of 2.
When you go from 3 to 1. Okay, can you come again?
So like it will work uh fine.
Yes, it will work.
Whole left subtree. But when I came to right subtree, like from 1 to when I went to 3, the 3 has to be appended in the list of 2, like in which the 2 is present, right?
Can you come again? The last line, the 3 has to be.
Appended in the list in which 2 is already there, like this.
But we are merging it now at 1. Merging only happens when you will get this also and this also.
Yeah, post order.
Just thinking that. Whatever way you think, post order, pre-order, what I'm trying to say is at the end, when every calculation for that particular node is done, then only we are doing it. We did it for 2 because for 2, left and right both are done. We will only do the merging for 1 when we have the calculation for 2 and 3 both. We will not do the calculate. We will not merging when we have only 2. If you go to the code, all the merging calculation is only done at the end. Here. When we know the left and right for each node. That means whatever was under that node, it is covered. It's done. So if you are saying we have calculated for 1, that means we are done whatever was there below the 1. Otherwise, that condition was never going to get hit. Okay. Does this code make sense now? This is what you need to learn specifically in recursion to play with the code and go with this way.
Right.
Okay. Anything in this question you want to discuss? Like why, if you still feel that level is still required in any way?
No, like I got that part, like why it will work. I'm getting that feeling, but like I have to dry run it myself also, like to get
Oh,
more clarity.
yeah, no issue. Anything else till now, whatever we have covered? So actually, I forgot to provide the list. I'll just keep a note of it that I need to give the list for recursion, backtracking, and all those things. Recursion, backtracking, entries, question list. Make sure you watched the entire thing from the last lectures because we are going to be heavily use it in the upcoming sessions. All the tree graph is heavily dependent on whatever we have covered in the last few sessions.
Sure, sure.
And I have explained there like how to even write the code for recursion tree, everything, whatever we have discussed today. It's already there. So you will get a better understanding to write the code for combination sums and those subset sum problems. Okay. Anything else? Any question, specific question you have for me? Anything you want to discuss?
No, like so like we'll get the practice sheet for tree now, right?
Yeah.
Or
So for
recursion.
recursion, yeah. So I think from last session I forgot to share the recursion backtracking and trees. You will get a list of questions which you should try to solve. Yeah, so you will get that list. By today, I will try to upload it. I think tomorrow's session is also going to be more focused on tree, but we will start with few questions, few more harder questions actually, and then we will start working on BFS and DFS, and yeah, that's it.
Okay.
Yeah, any question, any feedback, anything?
Like one more question. So now the classes will held during evening or like or in the
Yeah,
morning.
so right now in my hometown, that's why the classes will be from 2 to 4 till this week only, for this week only, or maybe at most next week, upcoming Saturday, Sunday. But after that, it will be 9 to 11, the same thing which we used to do. But just because I'm in my hometown, so it suits me better. That's why we were doing it. But in upcoming days, sooner we will start. We will go back to our same track.
Okay.
Questions plus, then we will start with DFS. Okay. Anything else you want to discuss?
Yeah, like that was all. Like so like for interviews, how should we prepare? Like apart from giving contests on lead code.
I think make sure you have a habit of solving the random questions. Okay. So it should not be like that you are not able to solve some random question. So like for example, on lead code, since if you are solving questions on lead code, it's a lead code style thing. But in OA, you will not that get kind of questions. OAs are like more about stories. If you want to crack OA, which is the first part of getting the interviews itself, OA's questions are more revolve around story. They will tell you a long story initially. Just after seeing the story, people like students like or the learners start getting feeling that they are hard. But so you should start practicing those kinds of questions. You can track OA sheets. You must check the lead code discussion section where people used to post the OA's question which they have got in the contest, not in the contest, in their OA test, like it may be my Google, Microsoft, whatever. So you should like keep checking there and keep trying to solve those questions. They initially give you the story and then they ask you the questions because the question is so long. So few people are not even able to observe even the easiest question. So you should start preparing for those kind of things. The other thing, as I mentioned, you should have a practice of solving the random questions because anything can come up in the interview. They're not going to ask you what you know. They are going to ask like whatever they want. It's not going to be that they will ask very hard questions. But if you have not done enough practice or if you are not good enough, you will not be able to do it even. So you need to be really good with DSA algo. You should be doing more random questions. Maybe you can use lead code assessment thing. I'm not sure whether you have explored it or not. There's something called lead code assessments. First three options are they are not premium one. Phone interview, online interview, something like that. Where they start throwing you a random question with a timer. Okay, you can try that out and make sure you are able to solve the question within the timeline because yeah, in most of the interviews you will get 45 minutes to 60 minutes to solve two questions, two medium questions most of the time, or it can be one hard question also. So
Right.
timing is one of the very important thing there. Your communication, how you're going to communicate your solutions, how you will start thinking out loud there, how you will communicate all your thoughts there, and how you're going to write the code there. You need to use good variable names. You need to use your code should be more cleaner. For example, let's say the code which you have sent to me and the versus the code which I have write you. So what was more cleaner? If you talk about that Zoro operator one, so the one which I wrote was more cleaner and was more clear basically. So you know to make sure the code which you are writing there is more clean. You are using correct variable names. You are not using ABCD or whatever those shitty names. So though all those things are very important for interviews. And for OA, you need to really prepare good because OAs are the first two steps are the hardest part of the entire interview process. First one is getting the OA, and the next one is cracking the OA. Rest of the rounds you will see it easier. I'm not saying easier, comparatively easier to the rest of the two ones.
Right. Like the issue which I am facing right now, like I am able to solve the question at the end, but the issue is like it either take 10 attempts or 9 attempts. Like it's very rare that I am able to solve the question in the first attempt itself.
That's fine. It's just a starting. How much time you are taking? That's what more concerns me.
Time,
If,
but also
if
issue.
if you are saying that your 10 attempts are done in 30 minutes, then maybe your mindset is about more trying faster and like failing first and then I
Yeah,
mean
that's the issue. Like even after just trying the test case, I think like this should I have think of like this edge case I should have think of this type of thing.
yeah, so initially these things happen. So I see everything will not come out of your mind like a magic. Some things you will learn from by some you will get to learn few things by only making mistakes. So you need to make sure that you are remembering those and not repeating them. That's what is more important for me. It's not about like, hey, I am like taking so much time on that thing. No, are you learning enough from them so that you are not repeating in the next one? Is not, it's the more important one.
Right, right,
And maybe your mindset is more about it, try to solve the question more faster and faster. In that way, sometimes what people do is they just focus more on solving the problem than thinking that hey, we should solve the problem in a single attempt. So there can be mindset thing also. But at your stage, I would say focus more on learning. You don't need to at initial levels. Too much optimization is not good. Okay, first become good with DSA algo, writing the code, how whatever. If you are able to think something, you should be able to write it. If you are not reaching at that stage, that means you need to start writing more and more codes. Definitely recursive codes you will have to write more. That is where you will see more problems. So at your stage, I would say write more and more codes that will help you to become better. Try to solve more and more questions. Don't try to optimize too much at early stage. Once you have become good enough, then yeah, you should go for the optimizations and all those things. But if you start doing pre-optimizations very early, you will miss few of the learnings which you could have got in a better way.
right, right, right. Correct.
In which you are currently?
Sorry.
In which you are? I mean, your batch, like, what is your batch year?
Yeah, like I passed out last year only. Like I'm working in a small startup.
Okay, okay, not say make it. Yeah, I would suggest you if you think that you are already good enough with the DSA, I'll go and you can start giving the interviews. So just go for it. You will fail some interviews, you will pass some interviews. It's not going to be like you will pass all of them. So
Yeah, like that's the only thing. Uh like until unless you don't solve it in 1 or 2 attempts, like that thing is like really down your confidence. Like in
no,
interview,
if
that
you no, I don't think so. You should not think it that way.
right,
In see, cracking the interviews is not going to be about. So see, if you think that everyone who is working at Google, Amazon, or Microsoft, they are really good ones, I can tell you it's not that way. Okay.
okay,
If you are thinking that like people are really good at these companies, it's not that. I've been there, I know that thing. Cracking the interview is something different, working is something different. Your knowledge base, as you said that you are not able to do it in single attempt, second attempt. People don't run the code while you're solving the question. Every company don't run your code exactly at the time of interviews. But if you are making so often mistakes, then no one, definitely then you are going to be out. If you are saying that you are able to do it, and let's say you give the some one attempt, then out of 1,000 test cases, 50 was not getting passed. Then it's fine. You can say maybe some of the test cases which were very clean on like very corner one, you missed it out. Maybe the interviewer may also missed out, and they may even ignore it. You should not worry too much about that, frankly speaking. Oh, not all the companies run your code. If you talk about Google, they don't run your code. The interview, you just see it, and whatever they feel, they just dump their what they think about you in the docs. Yeah, a few companies run it. Like while I gave the Salesforce interview, they ran my code in front of me. So yeah, it depends on that. But don't be too much worried about first attempt or second attempt. Even people have got the job even if they have made some mistakes there. If you are not able to get it in first attempt, interviewer will like point it out mistakes. You should be able to get to know, hey, I made a mistake, then fix it. If you're able to do it, then I think it's fine enough. And I think you should start giving the interviews if you feel that you're good with DSL. Go. Don't wait for the day to come when you feel that, hey, I have become the awesome one, because that day is not never going to come. I mean, you will never feel that way.
Right.
Okay.
Yeah, definitely. So maybe I'll start giving interviews then.
Yeah. Start. See. Give few. You will get the idea. Okay. You will get if you will get the confidence also. You will get what are you actually doing wrong in the interviews. Your communication also. Those things are very important during the interviews. Like what are you thinking? It's not like just the end cases matter there for them. The process to reach to the end thing is also matters to them.
Right.
So I would suggest to give more and more interviews. That would be better for you actually.
Definitely. Yep.
Okay. Yeah. I think for today I don't have anything else. If you have any question, you can ask me. Otherwise, we can wrap up for today.
No, like that. That was all. Thanks for the advice.
Yeah. No issue. Okay then. Bye.
Thank you. Bye bye.
Bye.